Hello everyone and welcome to episode 11 of my Python tutorial series. Today we are going to finish our dungeon crawler from episode 10. If you haven't seen that episode, go watch it now before trying this one. We are almost done with the entire Python tutorial series, so let's get started and finish strong. Alright, now last time we programmed a whole bunch of stuff and that resulted in us having 3 actions for the player. We can either have the player inspect himself, we can have the player inspect the enemy, or we can have the player attack. Now, these are cool actions for the player to do, but we also want the enemy to do actions. So, let's do that. But before we do, let's organize our code a little bit, because we have this gameplay loop right here. And the gameplay loop is all of this code. Now, the gameplay loop needs to involve the player actions and the enemy actions. Let's just quickly sort out the code to be those two categories. So over here, I'm going to type player actions, and then down here, underneath the player actions, I'm going to make a new comment that says enemy actions. So now we have the two different sections clearly defined. And now in the enemy actions area, first of all, make sure you're only tabbed in once to be in the while true loop. Let's make it to where the enemy can do one of two things. Let's say that if the enemy is alive, which means it has 1 health point or more, then it will attack the player. Otherwise, it will die and get replaced by a new enemy. So let's think about this. All we need to do is say if enemy.health is greater than 0, then let's just tell the player what the enemy is going to do. I will say enemy.name attack. So now we've told the player that the enemy is going to attack, and now we just need to make it attack. Now, if you remember, we already programmed all of the attack code right here, and all we need to do is specify an attacker and a defender. So let's come down here and say attack, and then let's say the attacker is enemy, and the defender is player. This is literally all the code we need to do for the enemy attack because we've already done so much work last episode. We already set up the entire attack system, so we are actually done with the enemy attacking already. Now let's make it to where if the enemy is dead, then let's tell the player that the character's died, and then replace him with the new enemy. So I'll say otherwise, so else, let's print enemy.name has died. And now, let's get a new enemy. And remember, we've already programmed summoning a new enemy up here. So all we need to do is come down here and say enemy equals new enemy. And that's it. It's that simple. You should start seeing how useful it is to architecture your code at the beginning. Even though it was harder last episode, this episode, most of the stuff is going to be super easy to add. Okay, we've added all this code. Let's make sure it works. If I run it, it says, what is your hero's name? I'll type Meb. It says type in action. Let's just make sure everything works. I will inspect self, and we have an error. It says that there's no health attribute. And that's because I was really silly right here and typed in health instead of HP. Now let's run this again. I type inspect self. It works, and look right here. It's a small slime attacks, and then it misses. Their code is actually working perfectly. It printed that the enemy attacks, and then the enemy actually tried to attack. So the code is working. Now let's try to inspect the enemy, and it looks like the enemy is working just fine, and the enemy actually hit us. And now finally, let's attack the enemy. Okay, we attacked the enemy. Let's make sure the enemy's health went down, and yep, it went down from 8 to 3, so that worked. And now let's attack one more time, and look at that. It says small slime has died. So this worked perfectly. We actually killed the enemy. And if we inspect the enemy, we'll see that it has been replaced with a new slime with 8 hit points again. But we were never told that a new enemy appeared, so let's fix that. Let's go back up to our new enemy function, and then after we get all the stats from the text file, let's print, and then let's say name has appeared. Yeah, this will be good. Now let's try it. When I run it, I will attack the enemies. And then when I kill the enemy, it informs me of the new enemy that appeared. This is awesome. Now our combat system is very functional. Now, it's not complete, but everything we've programmed now works. However, we do have a bit of an issue, and that is, if I run this code, and I just inspect the enemy, and I attack, and I attack, and I attack, and I keep going, we can inspect self and see that my health is currently at -5. I am very much dead. However, I can still attack, and I can still do all my actions. So, let's fix that. Let's come down here after the enemy actions, because we want to check if the player's died after the enemy attacks the player. And let's say if player.hp is less than or equal to 0. Then let's print game over. And I'm actually going to use some dashes to make it look fancy. And then let's also ask the player for an input just to confirm that they want to try the game again. So I will say input, press enter to restart. Now the code will not continue until we press enter. But now if we run the code again, and we just keep playing the game for a while, we will see that it says game over, press enter to restart. But then if I press restart, I can just keep going. And so the game never actually restarted. I'm still dead. So let's fix that. Let's make it to where when you die, let's break out of this while true loop. So if we want to exit the while true loop, all we need to do is type in the keyword break. Now it will break out of the while true loop. But there's a bit of an issue. If this happens right now, you'll see that it says press enter to restart, or when I press enter, we're just done. There's no Python to type in. See, I can't attack, I can't rename my player, there's nothing that we can do. And that's because, of course, we broke out of the while true loop, so we got to the end of the code, and there's nothing at the end of the code, so the code's done. So let's fix that. What we are going to do is we're going to put literally all of this into a while true loop. So all the way up into the start of game code. That's when we get to name our player, and that's when a new enemy gets summoned. So right here, I'm going to type while true, and then select all of our code below, and hit tab to tab it in. Now all of the code is in this while true loop. Now if I run the code again, and I just futz around for a little bit, you'll see that it says game over, press enter to restart. When I press enter, it says what is your hero's name again? So now I can name my hero. And look at that, it says a small slime has appeared. So we just finished a fully functioning restarting system. So now we can play the game over and over again, even if we die. That's pretty cool. Alright, we have a cool system right now, but there is a bit of an issue still. Let's run this code and see what happens. It says, what is your hero's name? If I type map, let's say that I'm just starting out the game, and I want to inspect myself to see what my stats are. If I do that right now, then the enemy immediately attacks me. That's not very fun. Let's make it to where it only takes your entire turn for actions that really matter, not actions like inspecting enemies and inspecting yourself. So let's come back up here into the player actions area. And in the player actions area, so I'm going to say player actions left equals, and then let's say player.speed. Now if you remember, and I recommend you make sure that this is still the case, your player.speed should be 1. Do not change the speed. This is a feature for you to build upon after this video is done. But for now, just keep your player.speed to 1, so that way the player can take 1 substantial action every turn. And then under that, let's say while player actions left is greater than 0, and then let's have all of this code, so everything from the player input to the last action you can take. Let's put all of that tabbed in to this while player actions left loop is on. And now it will let you infinitely type in an action to do until you run out of actions that you're allowed to do. Now we get to pick what actions cost a speed. Now remember, you start with 1 speed right now, so all we need to do is make it to where the player actions left gets subtracted by 1 by every action we want to take a turn. So the inspect self, I don't want to take an action. The inspect enemy, I don't want to take an action. But attacking should definitely take an action. So after we attack the enemy, I'm going to type player actions left minus equals 1. So that just subtracts 1 from player actions left, which means this while true loop should be false, which means the enemy then takes its turn. Let's try that out right now. If I run this code, it says what is your hero's name? I'll name my character. And then it says type in action. Let's try to inspect self. And look at that, the enemy didn't attack me. Now let's try to inspect enemy. It also didn't take an action. But now when I attack, look at that. Once I'm done attacking, this small slime attacks back. Now we have a good way to implement free actions. And real quickly, since we've added a few things, let's clean up our code real quick. Now down here we have the death code for the player, so I'm simply going to comment it in. I'm going to say player death code. So now this is cleanly distinguished between the enemy actions and the player actions. And now there is a bit of an issue, and that is when we run the game, when we do actions and the enemy does actions, there's just a lot on the screen, and it's a little hard to follow. So what I'm going to do is I'm going to make it to where at the beginning of every turn, let's just print a whole bunch of dashes. So now when I run the code, there's a bit of a dash in between every turn. Now I can clearly see when a turn is over and a new turn has started. This is way easier to read now. Alright, we have a functioning game now. It actually works quite well. We get new enemies that get summoned when you kill the old enemy, and you can attack the enemy and you can see all the stats and everything works just fine. However, it's very boring. Realistically, if we're just attacking this enemy, it's the same small slime every time, and we always type attack. We just type attack, and then we type attack, and then we type attack, and then we type attack, and we keep going until we die. It's very boring. Let's fix that. Let's spice up the combat a little bit. So what we are going to do is implement our dexterity into the combat. What this is going to do is, if you remember in our dodge roll code, the dexterity gives us a chance to dodge the enemy attack, and the enemy also has a chance to dodge our attacks. So the first thing we need to do, of course, is to modify our character class. We need to make it to where we can modify the dexterity in it. So I'm just going to put a little bit of space here, and I'll also comment in some stuff. I'll say these are the game functions. Now, in the character class function, so remember, we should be tabbed in once to stay in the class. Underneath the take damage code, let's make a few new functions. The first one, let's define it as get tripped. And then I'll type self, and then damage. Now in here, all I want to do is subtract the damage that we took to our dexterity. This will make it to where we have a harder time dodging. So I'm going to do self.dexterity minus equals damage. So whatever damage we took to our dexterity will be subtracted from our current dexterity. But there is a bit of an issue. Let's say we have 5 dexterity, and we take 10 dexterity damage. We're now at -5 dexterity. That doesn't make much sense. Remember, dexterity is your chance to dodge. So let's come down here and say if self.dexterity is less than 0, then self.dexterity equals 0. So that way you can never go negative on your dexterity. That doesn't make any sense at all. Alright, so now we have a dexterity roll. Let's come down here and make a new method. By the way, method simply means a function inside of a class. And let's recover. Recover self. Now down here, let's say self.dexterity plus equals random.rand int 1 and then comma and then integer of self.max dexterity over 2. Now let's talk about what this does. What this does is when you recover your dexterity will have a random number between 1 and half of your maximum dexterity. So if you have 10 maximum dexterity, it will let you recover somewhere between 1 and 5 dexterity. This is a pretty fair system in my opinion, but we still have an issue. Let's say our maximum dexterity is 5, which it is, and we recover. That means we're going to add somewhere between 1 and 3 dexterity to our current dexterity. So then we're going to have 8 dexterity, even though our maximum is still 5. So let's do the same thing that we did with the get tripped, but the opposite. So we're going to say if self.dexterity is greater than self.max dexterity, then self.dexterity equals self.max dexterity. So all that means is if we have 5 maximum dexterity, but our current dexterity is like 50, then it'll reset our dexterity back down to 5 because it's not allowed to be higher than our maximum. And actually, we can add these functions already into the game. The first thing we need to do is make it to where we can trip the enemy. So in our game functions area, under our attack section, let's simply make a new function. So I will define it as attempt, trip, and then in parentheses, let's again specify an attacker and a defender. And then in here, I'm simply going to make a simple coin flip. It's just going to be a random 50% chance if you successfully trip. That's going to be very simple for us. So I'm going to type if random.randint, and then 0, 1. That simply means when this random number gets rolled, it will either be a 0 or a 1. And then let's say if it equals 1, print defender.name has been tripped. So I will simply call our new function that we made up here, the getTripped function, and say getTripped. We need to specify the damage dealt. So let's come down here and go to the trip function and say attacker.strength. So however strong the attacker is, that's how much the enemy will get tripped by. And remember, when you get tripped, that means you're more likely to take damage from other attacks. So now there's a bit of a strategy to the game. But now let's say if this doesn't work, let's just tell the player that it failed. So otherwise, else, print defender.name avoided getting tripped. So now we have this function. Let's just run the code real quick to make sure there are no errors. And I'm having no errors, so that's a good sign. If you are, just make sure that you spelled everything correctly, everything's correctly capitalized, and that you haven't missed any colons. So now that we have the attempt trip function, let's make it to where we can actually call that function. And under the attack code, I'm first going to make sure I'm not indented in the attack code, just in the while loop, so I am indented 3 times. And then I'm going to type elif player input equals trip. Now let's make it to where the player can trip the enemy. So if we come up here, we see that our function that we just made is called attempt trip. So I can come down here and simply type in attempt trip, and then let's check. It says we need an attacker and a defender. So we can go back down to our code. We can go into our attempt trip parentheses and type in the attacker, who is the player, and then the defender, who is the enemy. Now let's try to run this code. It says, what is your hero's name? I will type in Meb, and I will attempt to trip the enemy. And we will see that there's an error, and that is because we did a silly. If we come back up here to the attempt trip, we called get tripped, but we never specified somebody to get tripped, and that was my fault. We're going to do defender.get tripped, because otherwise it doesn't know who is getting tripped. But yes, now that that is done, let's try one more time. I will type Meb, and now a small slime has appeared. I shall attempt to trip it. It says small slime has avoided getting tripped. And then I'm able to successfully trip the enemy. Let's inspect the enemy and see what happens. The enemy's dexterity is now 0, but its maximum dexterity is 2. So it went down 2 when I tripped it. That's perfect. Our code is working excellently. So now there's a little bit more of a combat strategy, because now you can trip the enemy. But now let's make it to where the enemy can trip you. So let's go back down here to the enemy actions and say if the enemy HP is greater than 0, so if the enemy's alive, let's do another random number. So let's say random action equals random.randint, and then a random number between 0 and 1. Now, if the random action equals 1, then let's just do the normal action. But if the number is 0, so random action equals 0, then let's say enemy.name tries to trip you. And then let's simply call the function attempt trip. And then in parentheses, I'm going to type the attacker, who is the enemy, and then the defender, who is the player. So now let's try this code, and we'll see what's your player's name. I'll type it in again, and then I shall attack the enemy. And it says small slime tries to trip you. Meb has been tripped. Now let's inspect ourselves, and we'll see that our dexterity went down to 2 when it used to be 5. So now the enemy has a higher chance of hitting us because it tripped us first. Now there are a few issues. First of all, I forgot to add a space here, so that way the message will look a little bit better. And then secondly, what happens when we get tripped? We have a higher chance of getting attacked. We can't recover. Let's make a new recover action. So down here, let's do elif player input equals recover player.recover. Now we should be able to recover some of our dexterity if we type in recover. Let's try that out real quick. So I will type in Meb, and then I shall attack the slime. And then it says the slime attempts to trip me, so I can inspect self. And we'll see that my dexterity is currently at 2. So let me type recover. And now inspect self. And we'll see that my dexterity has been increased to 4. So recovering is working. Let's just add a few more quality of life features. The first thing is that the trip and the recover actions should probably take a full action. So let's type in underneath them player actions left minus equals 1 and do the same thing in recover. So now whenever we take the actions trip or recover, it'll actually take a full action and the enemy gets another turn. And then one more thing we can do to make the game feel a little bit better is when we recover, let's print how much dexterity we have. Player.name now has, because I'm using plus signs, I will stringify the player.dexterity. Dexterity. When I recover, it now tells me how much dexterity I have. So it's very useful and a good quality of life feature. All right, we have almost all of the game done. All we need to do is add 2 more mechanics, and then we're completely done. The first one is a random enemy. Now, if you remember at the beginning of episode 10, I told you to make a separate folder for the dungeon crawler stuff. Now, this is really important. If you haven't done this, do this right now, because we are going to be adding a whole bunch of new files. So what we are going to do is we are going to randomize what enemy spawns, because right now we only have the slime, and that's pretty boring. So now let's make a new text file. This new text file is going to be our new enemy. So I am going to name mine Bandit. The bandit's going to be a little scarier than the slime. And I've actually prepared a little template right here for us to reference while we make the bandit file. So let's open up the bandit file and see that the first thing we need to add, just like we did the slime, is the name. So I'm going to name my enemy Bandit. The next thing we need to do is add the health. So I'm going to set this enemy's health to 7. The max HP is going to be 7 as well. The strength, well, bandits aren't very strong, so we'll make it 4. The dexterity, they're very dexterous, so I'm going to make it 8. The max dexterity will also be 8. And then the speed will be 1. So now we have a bandit file. Now let's go back into our code and make it to where the enemy is randomized between our slime and our bandit. So at the top of your code, after the character code, let's make a little variable right here. I'm going to say enemy list equals, and now we're going to use an array. So I'm going to use brackets to make a new array, and then I'm going to write the names of all of our text files that's in this folder. Now remember, this will only work if you are in the same folder as this text file. If you put them in different folders, it won't work. There are ways to make it work, but we haven't done that quite yet, so we're not going to right now. And now we're going to go down to this new enemy function and get rid of slime.txt, and instead replace it with random.choice. And then in here, I'm going to type enemy_list. Now it will take our enemy list from up here and randomly select one. Let's try it. It says, what's the hero's name? I'll type in Met. And we will see that a small slime has appeared. Now let's see what happens when I kill the slime. Look at that. A bandit has appeared. So a random enemy is spawning every time. And in fact, let's just make sure it works and inspect the enemy. And we'll see that the enemy has health 7, max health 7, strength, dexterity 8, and max dexterity 8. So it got all of our information from the file we made. So now you can probably tell we just made a system where you get to add as many enemies as you want, simply by using this little template, which I will link in the description of the video, or you can also just reference it here, and we can just add as many files as we want in here. Now remember, whatever files you add in here, you also have to come into here to the enemy list and add it to our array. If you don't do that, it will never show up. So make sure to do that. So before we go crazy, let's add the last feature to the game. I'm going to come back up to the top of the game where we have our enemy list. And down here, I'm going to add a new variable. I'm going to say potions equals 0. That's it. We are going to make a healing potion. Because if we run the game right now and we attack the enemy and we just keep going, we can play this pretty well and make sure to inspect the enemy to see what stats they have and try to trip the enemy, so that way we have a higher chance of dealing damage to the enemy and we can keep going and be strategic and everything. But eventually we're going to take so many hits that we're going to die, regardless of how well we play. So let's make it to where the player can get healing potions, which will allow him to heal. So let's come down here to the enemy death code and make it to where when the enemy dies, let's say if random.randint, and then I'm just going to do a 0 and a 1 again, equals 1, potions plus equals 1. And then I'm simply going to print, you found a potion. Type potion to drink it. But now we need to make it to where the player can actually drink the potion. So let's come back up here to the character class, because we're probably going to have some healing stuff eventually in this game. And after the recover, still in the character class, so tabbed in once, I'm going to type def heal self points. Now here I'll say self.hp plus equals points. So it's just the same thing as we did over and over again for the dexterity, recover, and for dealing damage and all these things, right? We're just adding health points. And then we'll also cap it. So we'll say if self.hp is greater than self.maxhp, then self.hp equals self.maxhp. So now we can only heal up to our maximum health. Okay, so now let's let the player actually drink the potion. So I'll come in here and type in elif player input equals potion. Let's say if potions is greater than 0, then let's have the player dot heal 10 hit points. And then let's come down here and say potions minus equals 1. So we subtract 1 from our current potion count because we drank it. And then in here, let's also tell the player how much health they're at. So I will say player.name is now at, and then I will say stringify player.hp, HP. There we go. Now the player will know how much health they have left. And then finally, let's say player actions left minus equals 1. I think it should take an action to drink a potion. If you think otherwise, you are more than welcome to remove that line. And then let's say otherwise, print, you have no potions. Now let's try to run the code, and you'll see that it says, what is your hero's name? I'll type in Meb, and then I shall attack this enemy. And we see that once I kill the enemy, I have a potion, and I can type in potion to drink it, and now I'm back up to 10 health, even though I was very low. And now I can try to drink potion again, but I'm out of potions, so it just says you have no potions, type another action. So we are actually completely done with all of the mechanics for this game. This is it. We've made all of the mechanics. Look at all this code. We've made combat, we've made tripping, we've made potions, we've made random enemies, we've made custom names. All of that stuff is all in this code. You should be very proud of yourself if you've gotten this far. Now there is one more thing I'm going to do just for a little bit of player fluidity, and that is elif, and then player input equals list actions. Then let's just tell the player all the actions you can take. You can take inspect self, you can do inspect enemy, you can attack, you can trip, you can recover, and you can drink a potion. So now, if the player doesn't know what to do, they can type list actions and it'll tell them all the actions. But the player doesn't know that they can type in list actions either. So I'm going to come down here and type in elf. They're going to type in something, and if it's not inspect self, it's not enemy, it's not attack, it's nothing else. It's none of our commands. We can say print unknown action. Type list actions to see a list of possible commands. So now if I run this code, I don't know what to do. It says type in action. I don't know. I'll try to jump. And it says unknown action. Type list actions. So I can type list actions. And it tells me all the actions I can take. So now the game's a lot more user-friendly. And of course, there are a plethora of new mechanics and features that you can add to your game. For example, something I did for mine is I came up here and imported time, and then made it to where in between every action I take, there's a little bit of a delay. See that? How all the actions have a little bit of a delay? Makes it feel more like Pokemon, which I think is pretty cool. But yeah, so that's an option. Another option, which I'm sure many of you will take, is to add way more enemies, right? We only have 2. You already know how to make enemies. We already programmed the entire system to work. All you need to do is add some new files, and then make sure that once you add the files, that you add it to your enemy list. But yeah, there are many things you can do. Leveling up, changing speed, allowing the player to pick their stats, maybe adding multiple enemies if you really want to give yourself a challenge. There are basically infinite things you can do. Add some more actions, try some enemies, do a whole bunch of stuff, make the game better than what I showed you, and have a lot of fun doing it. Hopefully you enjoyed learning so much about Python. This is my last episode in my beginner's introduction to Python. I may do more Python episodes in the future, but for now, this is all I have for you. Thank you very much for watching, and I will see you in a future project. Have fun and farewell.